Our solar system is a place of wonders. It's filled with planets, asteroids, and comets, all dancing around a single star. And then there is Jupiter, the king of planets, a gas giant so immense it could hold all the other planets inside it. But orbiting these giants are worlds that are just as fascinating. And among all the moons in our cosmic neighborhood, one stands out. This is Ganymede. Ganymede is not just any moon. It is the largest moon in the entire solar system. In fact, it's bigger than the planet Mercury. If Ganymede were orbiting the Sun on its own, we would undoubtedly call it a planet. But it doesn't. Instead, it is locked in a gravitational embrace with Jupiter. It is one of Jupiter's 4 largest moons, discovered by Galileo Galilei over 400 years ago. These moons changed our view of the universe forever. So what is this incredible secret that Ganymede is hiding? It is something invisible yet incredibly powerful. It is a magnetic field. Our own planet Earth has a magnetic field. It is generated by the churning molten iron in our planet's core. This field surrounds our world like a protective shield. But moons are generally thought to be too small. They should have cooled down long ago, and yet Ganymede does. It is the only moon in our entire solar system that generates its own magnetic field. This discovery, made by the Galileo spacecraft in the 1990s, was a complete surprise. It challenged everything we thought we knew about how moons work. As Galileo approached Ganymede, the magnetometer detected a field that was not Jupiter's. It was a dipole field, like a bar magnet, originating from inside the moon itself. This field was creating its own small magnetosphere, a protective bubble carved out inside Jupiter's larger one. It broke the rules for what a moon could be. The next breakthrough came from the Hubble Space Telescope. Scientists wondered, if Ganymede has its own magnetic field, could it also have its own auroras? Hubble captured the first ever images of auroras on a moon. They appeared as 2 shimmering ovals of light, glowing faintly over Ganymede's north and south poles. But Hubble's precise measurements showed they were only rocking by about 2 degrees, not the expected 6. Something was acting as a brake, damping the motion. The most plausible explanation was a vast, electrically conductive layer beneath the ice, but not just any liquid water. Pure water is not a very good conductor of electricity. However, if you dissolve salts in it, like the salt in Earth's oceans, it becomes an excellent conductor. The data strongly suggested a huge global ocean of salty liquid water, hidden deep beneath Ganymede's icy crust. This ocean would be vast, containing more water than all of Earth's oceans combined. It would be a dark, alien sea sandwiched between 2 layers of ice. The picture that emerged was of a moon with a complex, layered interior. At the very center lies the core, the engine of the primary magnetic field. The data strongly suggests this core is, at least in part, liquid iron. This liquid core would be the engine driving the magnetic field, a hidden powerhouse deep within the moon. For Ganymede's dynamo to work, this iron core must be at least partially liquid. But how could a moon, so far from the sun's warmth, have retained enough internal heat to keep its core molten for over 4.5 billion years? This question became a central puzzle for planetary scientists. One possibility was tidal heating. Ganymede is locked in a gravitational dance with Jupiter and its neighboring moons. This constant pulling and stretching generates friction and heat deep inside the moon. A combination of leftover heat from formation, radioactive decay, and perhaps a small but steady input from tidal forces all likely contribute to keeping the core from freezing solid. Ganymede seems to have hit a geological sweet spot. It was large enough to retain heat, but perhaps not so large that its internal convection became too slow to sustain a dynamo. When astrobiologists search for habitable environments, they look for 3 key ingredients: liquid water, essential chemical elements, and a source of energy. The story of Ganymede's core has shown us that this distant moon might just have all 3. The heat from the core could create hydrothermal vents on the seafloor. These vents could release heat and chemical nutrients from the rock into the water, providing the energy foundation for a potential ecosystem. The evidence suggests Ganymede's internal conditions have been stable for billions of years. This gives any potential life a huge amount of time to emerge and evolve. Fortunately, the next generation of explorers is already on its way. Leading the charge is the European Space Agency's JUICE mission, launched in 2023 on an 8-year journey to the Jovian system. JUICE will perform numerous flybys before taking a historic step. In 2034, it will become the first spacecraft ever to enter orbit around a moon other than our own, making Ganymede its primary scientific target. The secrets of Ganymede's core and ocean are within our reach, and the next decade promises to be one of incredible discovery. In the heart of Jupiter's giant moon, we have found a place that continues to inspire, to challenge, and to fill us with a sense of awe.